This podcast is proudly sponsored by Gyro Drilling. They provide world-class drilling solutions for all types of projects. They specialise in auger, aircore and RC drilling. Head to the team at Gyro Drilling for all your mining needs and see how they can help you with your upcoming project. Hello, I'm Ben Kostrich and this is the Market Bull Podcast. As this podcast grows, every subscriber helps. From those of you who watch this on YouTube or to those that listen on Spotify and Apple, every follower helps. If you do this one favour and hit follow on whatever platform you find us on, I promise I will continue to look and find fascinating people across the world and bring their perspectives to you. Thank you and enjoy this episode. So hello, I'm Ben Kostrich and this is the Market Bull Podcast. Joining me in this show today is Jon Price, the Managing Director of Richmond Vanadium Technology, which is listed on the ASX under code RVT. We were just discussing it listed in December of 2022, arguably just before 2023, so relatively new on the ASX, and some may not be familiar with it, but welcome to the show, Jon.
Great to be here, Ben. Thank you.
When I heard about you, I was like, I've never discussed vanadium on this project, and probably a lot of people have heard of it, seen it on the chemical tables and heard about its uses, but maybe not so much in the modern day era. But before we dive into all that, I want to get a bit about your backstory and your history. And I mean, I was researching, an environmental science degree from Griffith University in Brisbane, and now we're talking in Perth, so clearly it was a change over time. But yeah, what's your history in the mining and I guess working scene?
Yeah, so I studied in Brisbane, environmental science, and then headed west and studied metallurgy and mineral economics for my sins. So, and then, 30 years pretty much in the gold and the tantalum business throughout Western Australia and a little bit international. So really building processing plants, optimising them, then moving on to starting mines and managing operations, then through into the corporate world, managing director through Phoenix Gold, and then into Horizon Minerals, and now into Richmond Vanadium. So it's been, a really good journey. I've been lucky to have a lot of really good mentors, work with some fantastic teams in what is a brilliant industry that's the backbone of the country.
Yeah, so you clearly have a bit of a niche, especially in a liking to the mining. And as I'm finding out that people have had a lot of experience and then they almost take on these exciting new projects. And I think this is a time where, the EV revolution and just batteries is just calling for new innovation. And that's where we'll dive into now, which is Richmond Vanadium Technology. So talk me through, I guess, your introduction to this company and what was really the journey or interaction as to how did you become the managing director?
So the project sat in Horizon Minerals for many, many years. So you had gold assets sitting alongside vanadium assets, and vanadium price back then was probably $2 a pound. So we ended up doing an earn-out or a farm-out to a company that worked on the project for about 5 or 6 years. They earned up to 75% of the project, and then we felt that it was better in its own company. So we spun it out of Horizon Minerals and listed it under its own company to give it clear direction, a clear board, and a focus on vanadium and vanadium only. And Horizon was ready for a new person after 7 or 8 years now, I suppose it was with Horizon, moving into mining. So a mining engineer stepped into the CEO role at Horizon Minerals, and I saw an enormous opportunity to do something different and do something very special for this country, and that is to get vanadium onto the map, and particularly around the energy transition and the critical mineral space. So I was the non-exec director there for a while through the listing, and then July 1 took on the role of MD, and the previous MD gladly and happily sat in the non-executive role, which we're very thankful for. And now we're ready to move the development of the project forward. So for me, it was a really big opportunity to do something a little bit different to gold in a critical minerals environment, but really about energy transition and vanadium's part in that.
And would you say that's predominantly part of the company's mission? Like, when you're looking, vanadium's in the name, it sort of makes it a bit easier to understand what you're looking for. But more so, what's the company's mission? I mean, what are you really striving to achieve?
Obviously, the development of the project. We've got one of the world's largest projects up in North Queensland. So development of the project, but more the incubation of a new industry. We have a lot of vanadium in this country and we produce none. So we believe that it's time for that to change. We have a very advanced project and looking to get that into production in the next couple of years, at a time where vanadium is now more known. It's a little known project, I suppose, the best way to describe it, but more and more people are starting to realise, well, vanadium is in batteries, and batteries is a big part of the energy transition's future. And that's what got me excited. So the mission, develop the project and incubate the industry from not only raw material and delivering a concentrate, but trying to get all the way down that supply chain into the batteries themselves and into electrolyte manufacturer. And I think that's going to be a transition in itself, but we've got the opportunity to create a raw material to battery chain for the first time from scratch. And that's what's exciting.
Yeah, Australia hasn't really gone down that path very much. We're very much a country that finds these commodities and resources and ships them off, and it echoes a bit of what I've seen in the presentations and what you've talked about, building in that supply chain. But if take a step back and focus on the electrification future and vanadium's place in it, if we're setting the scene for where vanadium sits in this electrification future, I mean, how do you look at that and the global supply and the current sort of picture for it?
Yeah, so vanadium, like a lot, is dominated by China. So the production of vanadium currently is around 120,000 tonnes a year. And it comes from 4 countries. So you've got China, Russia, South Africa and Brazil. We have in this country the 3rd largest resources of vanadium on the planet and the 2nd largest reserves of vanadium on the planet. So the opportunity to take the raw material and get into the battery space, we have the type of material that's suited for the batteries. Stationary, long duration batteries are a key. So 10 years ago, we had solar, we had wind and other renewable energy projects coming on stream, but the grid couldn't handle it. It had to have that intermittent storage. So that's where vanadium and the vanadium redox flow battery really comes into its own, to be able to store energy from renewables. When the sun is not shining, the wind is not blowing, that battery will then release energy that has been stored during the daytime and give it back during the nighttime. And I think there's a world recognition now that we have to have intermittent battery storage for stabilising the grids as they are and as they will be in the future. And that's the way the grids are going to change. So we're going to see macro grids, which are what is in place now, and we're going to be moving into microgrids and nano grids, and they are grids that look after their own power generation and store their own energy, and they are a microgrid to themselves without any reliance on, hopefully in future, zero fossil fuels.
Interesting. Yeah, because we were talking before we started about, China really beating the drum and accelerating quite quickly. Same with a bit of Europe. And we've seen really Australia sort of lagging a little bit behind. We've sort of, we're a bit slow to the party in some regards. But as you said, there's a massive opportunity. But you talked there about 4 countries having pretty much global control over the supply. And we've seen issues over the last handful of years of the impact of that. So if we look quickly at just, the opportunity that Australia has, you talk about the amount of vanadium. Where does that position you guys in the opportunity spectrum?
Yeah, so on vanadium, 90% of vanadium itself is used in the steel industry, predominantly for rebar, construction steel, specialty alloy steel, aerospace, defence. And we see, the future demand of that being relatively flat over the next 10 to 15 years. Where we see the demand coming from is the adoption of the vanadium redox flow battery. And that battery is now being adopted almost exclusively in China, North America and Europe. So lithium batteries, when you look at a 4-hour plus storage time frame, they really aren't the best battery technology for them, and I'll take you through why a little bit later. Yeah. But from a pure supply-demand, the demand is going to come from the battery industry, and that's going to come from the energy transition. So if every country is to meet these energy transition targets that they've set for themselves, they have to increase the adoption of the vanadium battery and other flow technologies. And we see in the next couple of years a massive shortfall of supply. So the current supply from the 4 countries will essentially feed the steel industry and continue to do so. What we see in 26, 27 is about a 50 to 75,000 tonnes a year shortfall. And the world only makes 120,000 tonnes a year. So the question is, where is this supply going to come from to meet the demand? And we believe that Australia should be at the forefront of that to grab that market share. And our project, our initial production rate is around 12,500 tonnes per annum. That's 10% of current world supply. So it's a global scale project delivering a global supply tonnage. And we have the ability to scale that up as demand dictates. So supply currently will feed current demand. Future demand needs new sources of supply. And Australia should be one of those countries that take up that opportunity.
Yeah, the battery, I mean, that's quite a damning sort of outlook there. I mean, it's the same applies for a few other resources, but this battery technology sounds incredibly interesting. And a lot of people just go, oh, EVs, everything's lithium, and that's sort of that almost connotation that that's the only storage device or technology. So take us through a little bit of this redox battery, this vanadium redox battery, and talk about, you know, where it's really come from, and I mean some of the benefits it's got for its particular use cases.
Well, it came from the University of New South Wales, invented here in this country in the 70s. So from that period, a lot of technical advancement has gone through. We're up to essentially Generation 5 batteries now. The cost of the batteries are coming down significantly. So lithium is a mobile battery. That's where they should position themselves. So anything that's mobile, car, phone, laptop, vanadium batteries aren't going to go into a car anytime soon. But all of those devices need to be charged. And where those charging outlets are still fossil fuel. So the EV market can deal with 5% of our reduction of carbon emissions. But the other 95 is really at the grid, power generation, fossil fuel end. And that is where renewable energies come in, and that's where the battery comes in. So the batteries themselves are a liquid stationary battery. They're large in scale, they're sea container size, and they are all liquid. So they're all vanadium and they're all liquid. So they do not have a metal electrode. And if you have a metal electrode in any battery, it degrades. And it degrades over time. So a lithium battery will typically last 7 to 10 years. A vanadium redox flow battery will last 25 years. And then
big difference there.
The electrolyte within it has an infinite life. And people go, no, nothing can have an infinite life. But ultimately, this is just a charge change to receive energy and to discharge is just a change of oxidation states of vanadium itself. So on the periodic table, there is not too many elements that have a multitude of different oxidation states that can allow it to receive energy and discharge energy continuously. And the vanadium metal is one of those. So we have a large tank. If you want more energy storage, you just have a bigger tank. If you want more power, you just have larger cell stacks. And that's where they come into play. And there is a multitude of benefits over and above why they are superior to the lithium big batteries. And lithium's done a good job. They've got market share. They're probably 90% of the world's big batteries now are lithium. What's starting to change in China, Europe and North America is that as duration of the battery goes past 4 hours, the lithium batteries can't compete. And they are a heat-generating battery. So you've seen in the media there's a lot of talk around fires and all that sort of stuff. The vanadium redox flow battery is cold. It doesn't have any risk of fire or explosion, and that gives it a lot of benefits. The main one is you can actually put them very close together and actually stack them on top of each other. And you can get up to gigawatt-hour scale. So the largest vanadium flow battery that's in use at the moment is 400 megawatt-hour going up to 800 megawatt-hour. And under construction is about 5 gigawatt-hours of vanadium batteries going in Asia and through North America and the European continent. So they're getting it. And they want 8-hour storage. You know, Germany is a good example. They want 8 to 10 hours of storage because the sun's not out. And they need more storage. And the longer the storage, the more superior the vanadium flow batteries are.
Yeah, I mean, you can just see the use cases there exactly about the battery storage, the energy storage rather. It just paints a massive picture, and we'll go through a bit more about, you know, maybe when the other countries are really going to thrive, mostly just as Australia. But if we focus now back on Richmond Vanadium Technologies. We talked about the project a little bit, but if we drill down, I know there was a few comments about, you guys really, and you said it before, this mine to metal battery strategy. And for those that are unfamiliar with where the project is and what you're trying to achieve, can you talk us through a little bit about where it is in Queensland and some of the history of that as well?
So Richmond Vanadium's in the town of Richmond, so that's halfway between Townsville and Mount Isa. So it sits on the major infrastructure corridor where the Flinders Highway, the railway, the new copper string power initiative from the Queensland government. So we've got a fantastic address in the middle of historic sort of cattle country, so we're not in the rainforest. And there is a massive amount of vanadium up in that region called the Northwest Minerals Province. We hold a JORC resource of 1.8 billion tonne. So we talk about it being world scale, it truly is.
Yeah.
It's got one small part of that resource has got 110 years of mine life at our forecast production rate. So it's got power, rail, road, all the infrastructure that you could need. It's got a state that is slowly transitioning from coal mining, from fossil fuels. So there's a great skill set there that can be transitioning into a new industry. So we've got all the ingredients to actually build a world-class, world-scale vanadium mine. And in the region, there's probably about 7 other companies doing similar things in that area to try and get up and away. And if you look at the supply-demand equation for 26-27, we nearly all need to get up and away, including our friends over in the West Australia guys in the titano-magnetite. So there are different types of ore, and there are different companies at different stages. So we've got our JORC resource. We're working on our bankable feasibility study, and we are working with government as a critical mineral and a coordinated project to get our approvals done middle of next year.
I mean, there sounds like a lot going on. When I was on the website, I saw there was quite a lot of timelines and projects. I mean, can you allude on a little bit more about what we can really anticipate happening at the company over the next, 6 to 12 months and what really investors can expect?
Yeah, so on the back of the positive pre-feasibility study that we released, we virtually went straight into the bankable feasibility study, and that's getting into that final development decision for the back of 2025. So the next 12 months is a lot of technical work. We're doing a vast array of technical optimisation and verification of the process flow sheet. This is new. This ore body is unique. So it needs to be tested, retested and confirmed that the process flow sheet is going to deliver. We're doing some more drilling in the next couple of months because there are different types of ore in the geology. So the next year is complete the bankable feasibility study, all the engineering, the process flow sheet design, the costing and the environmental approvals. So as mentioned, the Queensland Government awarded us coordinated project status, and that's probably a fancy term for a hand-holding exercise. So they will walk us through the whole approval process, both state and federal. And so we work with the Office of Coordinator General in Queensland and with the federal counterparts. So that's a really good opportunity for us to showcase to the state and to the federal government that this is a real industry. This is beneficial. We're actually mining a commodity very, very shallow. Our ore body stops at 20 metres below the surface. So it couldn't get much simpler in terms of a mine. It starts at surface, stops at 20 metres. So it's a very simple, low strip ratio oxide mine. Then we put it through a concentrator. That concentrator will deliver around 1.8 to 2% concentrate grade, which doesn't sound much if you're talking zinc or other things, but that's quite a high concentrate grade for vanadium. And then into a refinery process, which takes through to 98% vanadium pentoxide, which is the final product, which can then be turned into electrolyte and fed into batteries. So environmental approvals, all the technical work, the laboratory work, and the flow sheet design and the capital estimates and the operating cost estimates for us to make a financial investment decision back end of next year. So there's a lot to do.
Yeah, far out. And I mean, this probably goes into more about, we talked about at the beginning, the metals to almost the battery side of it, because, Australia, as we talked about at the beginning, very quick to send these resources and commodities offshore to do that next stage. Do you really, I've seen you talk about it actually, Australia with this opportunity, do you guys really see that you guys have got as a lot of the infrastructure already set, the potential to do the full supply chain model and almost have that final product ready for batteries? Is that guess, part of the mission as we talked about? Yeah.
It's a really good question, and it's a difficult question to answer because from a pure economic point of view, if you look at lithium, downstream processing for most critical minerals is very, very highly specialised and very, very highly technical, and that translates into very high capital and typically high operating costs.
Yeah.
So as a part of the bankable feasibility study, we are working on what is the capital differential, what is the operating cost differential, and at some point we need to understand from government, do you need or want this to be completely done here in this country because we are going to need some help.
Yeah.
Typically, lithium and vanadium is not an orphan. You get to a concentrate grade and you want to refine it. It is cheaper to refine offshore, and it's not a little bit cheaper. It's a lot cheaper. If you look at power, labour, reagent consumption, and we are a sulfuric acid consumer, the costs of some of those inputs are still very, very high, and that in vanadium is the same as the others. It can be too expensive. So we need government on board to incubate a new industry, and we're going to need to do it because we have shareholders to answer to.
Yes.
And we have an economic imperative to deliver to our shareholders. The government need to understand that, and they need to be part of the story. If they're not, unfortunately, it'll be like all other commodities where they get put on a ship and they're refined elsewhere.
Yeah, well, we're seeing that really with the lithium side of it. If you look at the potential synergies there of, lithium, there's a lot of talk of us trying to set up refining facilities here, but there's just been delays in costs. And I think you've seen big CEOs and companies say it's just more cost efficient to do it elsewhere.
Yeah.
And I think that really does put Australian government in a position where if we want to build this new industry, which is potentially refining all these resources, it sort of sounds a bit bizarre that it's cheaper to send it on a boat hundreds of kilometres away than do it on shore, which just baffles. But it's interesting, talk about specialisation and all of that. Do you see any synergies across some of the other sectors of the market and the ways that these, I guess, resources or commodities are processed and refined throughout your time, or have each one, of course, got these very, very differences, and that the world is slowly sort of trying to unpack the best way to apply new technologies to it?
Yeah, it's challenging because some of the processing flow sheets, they're all very, very different. They often use similar bits of equipment, but the way they're all laid out into a flow sheet is very different. And there isn't another ore body like ours on the planet. So there's nothing to look at.
Yeah, there's no sort of reference guide.
There's no reference point.
Yeah.
So it is doing something from scratch. So we call it a conventional flow sheet, but it's how you put all those bits of equipment together. So from a concentrator point of view, it is relatively simple. It's just a physical separation exercise through screening, through flotation to deliver the concentrate. Then the hard work begins. We need to be using sulfuric acid leaching. Then we go into a solvent extraction process, then a deammoniation process, and that specialised equipment is expensive, and the operating costs, particularly sulfuric acid, is very, very high. So what we want to do is we want to do it all in Australia. It'll just be about when. So for us to get going, it might need 5 years of offshore learning, understanding and looking at costs, and then eventually be bringing the whole supply chain here. And I don't think we should be really competing with China, and this is a talking point that we need to have the discussion. We have to collaborate as much as compete with them because their technology is so advanced.
They've been doing it for a lot longer than us.
Good.
Yeah.
And they're putting in 5 gigawatt hours of vanadium batteries in China as we speak. They've done a lot of the learning, they've made a lot of the mistakes, and they want to actually bring the technology here. They don't want to necessarily own the mine or own the port or own the railway line. They want to bring their equipment as you would bring a BYD electric car from China onto the road of Australia. They want to bring the battery into Australia. And that's what we're trying to harness and work through a transition process where assembly of batteries is Australia. Electrolyte manufacture is done in Australia. But the in-between part of concentrate to final product at present is telling us without government support, we are going to have to economically do it somewhere else in the short to medium term, and then eventually, hopefully, do it all in this country. So use the best technology that's there at present because it'll be less risky, the costs are coming down significantly, and we can learn from all the learnings of 10 years of work.
And not repeat the mistakes or find out the long way. Yeah,
exactly. So I think we have to be a little bit careful to say we've got to be decoupling to a point. But ultimately, the way I see it is embrace the technology because it's the best, and make sure it's brought in here and the opportunity is maximised in this country. And in some point in the future, we can do it all.
Yeah, and we go there. This year is apparently going to be very. I shouldn't say apparently is going to be very busy with the banking feasibility study. And when I was looking at it, the website was very clearly set out with the milestones and objectives and what was aiming to be achieved. And with this, you alluded to a bit of the team that was around you and the strong board and a bit of their experience and I guess the strategy behind it. Can you divulge a little bit about who's alongside you and, where their focuses and niche skill sets really lying?
So we're a pretty small group. We've only got about 7 of us. Our chair is Brendan Grill, so he was the leader of the National Party and worked with the state government for many, many years. And his key role is to discuss with state and federal government exactly what we've been talking about. So he's got an enormous amount of climate change experience and political experience. He can open all the doors that we need opened, and he's doing a fantastic job in that regard at state and federal level. We have Dr. Sean Wren, who was my predecessor. He's an economic geologist. He's an expert in the commodity. He took the project from an idea into something that's going to become very, very real in a fairly short period of time. So the work that they did through that earn-in period over 6 or 7 years was an enormous amount of test work in Australia and in China to get the flow sheet developed and to get the flow sheet right. Lily Zao is a mechanical engineer, so she's really focused on flow sheet optimisation, verification, and then the capital and operating costs to make sure you're going to put the raw material in one end and the right stuff's going to come out the other end. So she's focused on the bankable feasibility study. And our geology team that are up there drilling in May is really our chief geologist who knows vanadium backwards. So they're very, very niche in their skill set. They know a lot about vanadium. They know how to get it out. And they also know through their contacts in China how to get it out effectively. So vanadium's not rare in the Earth's crust. In fact, it's the 22nd most abundant metal on the planet. The trick for vanadium is to get it out cost effectively and actually make a margin out of the material. And that's probably why you've seen the Australian vanadium market not advance as quickly, because that capital barrier and that operating cost barrier has been prohibitive. But we see that the supply-demand equation is going to change that significantly with the adoption of the battery, that the price is going to climb, margins are going to be delivered, and we want to be one of the first to be producing vanadium along with our colleagues.
Yeah, it does paint the picture that all these commodities and resources have their time in the sun, and I think that the race of lithium, and it's had its few sorts of ups and downs, but it's really sort of brought a lot of these other resources to the forefront with these critical mineral acts that are all across the world, with electrification in the US and some of these government stimulants. All these materials are now coming to the forefront, and people are a bit more aware of their use cases. And I think it goes without saying that the redox battery for long-term storage is a solution to a problem that many people have been really looking for, and Australia and all other countries are no exception to looking for those solutions. But if I go back to, I'd like to summarise these conversations with the key 3 takeaways that investors can, or even listeners can, anticipate over the next 3 months, and predominantly more company focused, but could be also about vanadium itself. But what would be the 3 key takeaways that people should take from this conversation?
I think they should look into vanadium. There is a lot of documentation and it needs an education and awareness exercise. So everyone needs to understand that we're not necessarily competing with lithium. Lithium has its place and it's absolutely necessary. And we've seen the ups and downs in lithium, but it is necessary and it is needed. What you should be looking at is the vanadium supply-demand equation, which is out there for people who want to spend some time looking and doing some research. That battery in China, particularly now, lithium is not to be used. So they have mandated across the Chinese provinces that lithium batteries are not to be used. So the supply demand equation is going to deliver a massive shortfall of vanadium product. Tick number one, supply is not going to meet demand, so we should start to see upward prices, and that is obviously a good part of the investment thesis. Then you look at where is it going to come from in Australia. You look at the scale of Richmond project, 1.8 billion tonne. It's the largest of its kind on the planet. It is relatively simple to extract. It's easy to mine. It's simple to turn into concentrate, and it's relatively easy to turn into final product. So you've got a lower risk pathway from mining through to raw material. And then you've got, a government policy to a point where it's a critical mineral, and people need to understand why these batteries. Why aren't people using them? And there are a number of reasons why. There's reasons why they should be using them: safety, full recyclability, full depth of discharge, and the fact that you can scale these up to any scale you want just by changing the tanks, because they're actually decoupled from the stack. So these batteries are incredibly versatile, safe, 25 years life. After 25 years, take the electrolyte out of the battery, put it into a new one, and go for another 25 years. Lithium, 7 years. 3 times you've got to turn over a lithium battery to compete with a vanadium battery in stationary grid storage. So supply demand, the scale of the project and the ease of extraction and the cost of that extraction, and the global energy transition where they have to be adopted. Yeah. There is no other major technology. There will be in the future, but there is no advanced technology as good as vanadium. And the barrier to these batteries has always been upfront capital costs. The cost of the vanadium is around half the cost of the battery. So there are ways around that. The technology is bringing the cost of the batteries down. So if you look at a 1 gigawatt hour battery, they are cheaper than lithium batteries at about $450 Aussie per kilowatt hour. And you can look at that cost equation and say, okay, well, that's a high input cost. Don't buy the electrolyte. Lease it. So the vanadium never degrades and is fully recyclable and has an infinite life. Gold sits in a vault. Yeah. This renewable product can sit in a battery under lease, and all of a sudden the economics swing even more in the favour of vanadium batteries. So the three key is, please have a look at the tech, have a look at the batteries. There's some great YouTube stuff. Just Google, how does a vanadium battery work, and you'll see all the cartoons and the people saying, is it worth the hype? And go and have a look at it and look at it for yourself. The vanadium price is on the climb in 26, 27, and we are positioning our company to be one of the first to get vanadium out of the ground and start making product and start making batteries in Australia for Australia over time.
Yeah, again, alluding back to the beginning when you said, there's 4 countries that dominate the entirety of supply, and, with the project that you guys have got, when it comes there, if it contributes 10% of this, vanadium supply, because all of it needs to come online, it can't all just go to the steel and other areas. This is now an emerging giant sector of the market. It does sort of put a bit of precedence on good projects, good quality projects, and as you said, specialist team, a whole bunch of factors, but the awareness of what it is and where its use cases are. I think a lot of people do get stuck in, it's a lithium battery, it can be applied to all walks of life, and realising that vanadium batteries are much more durable for longer periods of time, life, but also for different charging or holding of energy, such as, solar, wind, and those that we've talked about. But yeah, for listeners that are potentially engrossed in vanadium now, and I'm sure there'll probably be some questions asked of, I wasn't aware of this and where can I go? But to follow yourself and more so the company, where can listeners go to keep an eye on Richmond Vanadium Technology?
First port of call is always our website. But I think there are a number of really good places to go and look, and Googling YouTube is actually quite a good way to look at it. There is a group called Vanatech. If you go to the Vanatech website and our other colleagues around the world, their websites, there's an enormous amount of information on the batteries, the detailed technical side of the batteries and of the mine. And there is a battery up and running in South Australia now by a company called Yadla Malka. They've got an 8 megawatt hour vanadium battery. So not only can you look and read, but you can you can see, touch, kick it, and start to have a look at the data. Yeah. And I think that's where a lot of people are at the present. They say, yeah, I've heard about it. Don't really know whether it can work or not. I need to see it first. In Australia, as you mentioned, we're relatively slow adopters, but we like to be maybe first to be second. So the batteries are in, they're not on the bench, they're not in the lab, they're actually now in mainstream use. And the batteries in Dalian in China, 400 megawatt hours, that's 200,000 homes.
It's massive.
So this is the scale that vanadium needs to play in. And we have probably at least a dozen vanadium batteries up and running, small and large, around Australia. So have a look at them, understand how they work, and then more and more data will come to go, well, hang on a minute, why aren't we using more of these? I don't believe we should have the big battery. The big battery in Geelong was only last year that one of the battery cells caught fire.
Yeah.
We don't want to see that happen. But ultimately, you've got mum and dad with high power bills. You've got an energy transition set of targets across the globe that people are starting to go, can we meet these? This technology can be part of that
solution,
target meeting, and part of that solution. So there is a lot of information out, and I suggest and encourage everyone to get out and have a really good look at it and understand it for themselves.
No, I appreciate it. It's, as I said, the first time I've gone down this path, and the battery storage is definitely you can only see it growing, and the awareness of that. Thank you for educating me on that. I was not aware of it. So, yeah, thank you so much, Jon, for taking the time to speak on the show. And I'm looking forward to seeing what evolves over the next 12 months and seeing how the vanadium global market unfolds, but more so the company itself. So thank you for speaking on the show.
Thanks, Ben. Great to be here.
Thanks for listening to the MarketBull podcast. Please remember that the topics and stocks discussed in this podcast are not financial advice. If you enjoyed this episode, please make sure to like, share, and follow. You can follow the MarketBull on all our socials and keep up to date with global market insights.